So we're going to start talking about trigonometry today and the idea behind a trigonometric ratio. Because what trigonometry does is it relates the side lengths of right triangles to their angle measures. So it kind of connects angles and sides. What mathematicians realized a long time ago was that if you took the ratio of the shorter leg to the longer leg in a right triangle, if it was a certain value, then the angle was a certain size. So for example, they knew that if there was a ratio of 3 to 5 between the shorter leg to the longer leg, then the angle opposite the shortest side was a 31-degree angle. So as you can see in these different similar triangles, I have a 3 to 5 side length ratio. And because the triangles that are similar by SAS similarity with the right angle, then all those 31-degree angles have to have the same measure. So anytime we see a 31-degree angle, we know that the side ratios are in a 3 to 5 ratio. Well, look at this. We can indirectly measure the height of a tree because we recognize that we have a 31-degree angle from some point away from the tree up to the top. That's called an angle of elevation. So if we know that angle is 31 degrees, we know that these side ratios then are 3 to 5. So write a proportion and solve for the height of the tree. And let's round it to the nearest meter. So we know the shorter leg to longer leg is 3 to 5. And that's going to be the height of the tree to 36. So if we do some cross multiplying, we get 5h equals 108. And h is about 21.6. So did you get 22 meters high? So this idea about trigonometry allows us to do some indirect measurement. But we got a problem though. I mean, it works for a 31-degree angle and a 3 to 5 side ratio. How many side ratios would we have to remember? Oh my goodness. So that's why instead of using similar triangles, we use trigonometry. And the ratio that we just used, the side that was opposite the angle to its adjacent side, we call that the tangent of the angle. So what we had was our right triangle. We have our angle here. This was our opposite leg and our adjacent leg. That ratio of opposite to adjacent was called the tangent of the angle. So on this next page here, you might want to take a moment and pause the video and write down some of these ratios here. This is a really, really key page. Mastering this page is going to make you very successful. Okay, so let's use this. So first, our trigonometry is always done in degrees. You should probably pause here again and make sure that your calculator is in degree mode. So now this time we're going to write a trig equation and we're going to solve it. So recognizing that I'm looking for this side here, the opposite side, based on my 31-degree angle, that side is my opposite side. So I got my opposite side over here. I got my adjacent side down here. So I know that opposite divided by adjacent is tangent. That gives me this ratio here, that the tangent of 31 degrees, is equal to h over 36. Now, before we go to the calculator for this, I want to do one thing. I'd like to get h by itself. So h is being divided right now by 36. So what I'll do is on both sides, I'll multiply by 36. So now my value of h is 36 times the tangent of 31. And I like to put the 36 first because I don't want the calculator to think that the angle's 31, maybe like multiplied by 36. So you'll see how I type into the calculator. And again, here's an expression that I can just carry with me. I just have to type it right in and I get my answer. Let's go to the calculator and try it. So I'm going to type 36 times. Now I have to find where tangent's located. So if you go over to the button next to the 7, you see the button that says trig. So I press trig. See it light up in red? And then you just have to scroll over to the one that you'd like. I want tangent. So I'll go over here to tan and I'll press enter. So now the calculator is saying, okay, the tangent of what? Notice it gave me some parentheses. So I want a 31-degree angle. And now I'm going to press enter. And I got about 21.63, so we're going to round that to 22 degrees. And that's about the same answer we got. Notice that we got exactly 21.6 because we said that it was about 31 degrees. When the angle is exactly 31, it's not exactly a 3:5 ratio, but it's really, really close. So h is about 22, so the height of the tree is 22 meters, the answer we got. No similar triangles here. We're doing trigonometry. Let's go through another one. So we want to determine the values of a and b. In this case, we're going to round them to the nearest tenth. So maybe I'll set up an equation to solve for a, and then I'll let you solve one for b on your own. So first of all, I recognize that my angle here is 70 degrees. The side that's opposite the 70-degree angle is 13. I'm looking for a. A is the hypotenuse. So I got to think back. What ratio involved opposite and hypotenuse? If I go back in my notes, let's see, opposite and hypotenuse was the sine of angle A. It was the sine of angle A. So I'm going to write the sine of my angle, the sine of 70 degrees, equals my opposite side divided by my hypotenuse, A. So now, how do we solve this equation? Well, if you want to think of it this way, you could do your cross multiplying. I get a times the sine of 70 equals 13. And remember, sine of 70 is a number. So if I divide it by the sine of 70, what I get is a is 13 divided by sine 70. So really what I could have done was just switch those two if my variable's in the denominator. In the numerator, it's pretty easy, just cross multiply. If the variable's in the denominator, maybe just switch the variable with the trig value. Let's go to the calculator, find our value. So we have 13 divided by, let's go to that trig button again and get sine. Sine of 70. And I'm rounding that answer to the nearest tenth, 13.8. So see if you can write and solve a trig ratio to find the value of b. I know you might be saying, oh, I could do Pythagorean theorem here. You're right, you could. Let's practice trigonometry. We need practice doing trig. So maybe take a moment, solve this, and then come back. So how'd you do for finding b? If I'm looking at b, b is adjacent. So I know the 13 is an exact value, so I'm going to use the 13 in here. So it looks like based on the 70-degree angle, the 13 is the opposite, the b is the adjacent. Tangent is opposite over adjacent. So I'm going to say that the tan of 70 is opposite over adjacent. And I remember from my previous problem that I can just switch the variable around. So b now is equal to 13 over tan 70. Let's go to the calculator and find out what that is. 13 divided by, go to trig, go to tan, press enter, tan 70. Nearest tenth, 4.7. And it kind of looks right to me, I guess. If the opposite side is 13, the hypotenuse is a little bit more than that. B is probably going to be a little bit smaller. So those numbers seem to make sense to me. So besides using trigonometry to find a side length, we could use trigonometry to find an angle measure as well. So check out what I'm going to do here. I'm going to find the measure of angle B in this case. So let me see. This is the angle I want to find, that one up there. So based on this angle, I know my hypotenuse and I know my adjacent side. Those are the two sides I know. So that's the cosine ratio. Find that in your notes. Adjacent hypotenuse is cosine. So I'm going to write that the cosine of B is equal to the adjacent divided by the hypotenuse. So let's take a minute and talk about how to solve this equation. Because sine, cosine, and tangents are functions. They're not operations. So we have to think about how we undo these things. Like, how do you undo squaring? Well, you square root it. You do its inverse. So we want to do actually what's called the inverse of cosine. If we want to solve for the angle here, the angle is equal to the inverse cosine of 8/15. And it's not really to the -1 exponent. You'll learn next year in math that the -1 here implies that it's the inverse of the function. So we can say it's the inverse cosine of 8/15. That's the equation we want to write. Let's go to our calculator. So again, I'm going to press my trig button. And notice, right underneath the cosine is the inverse cosine. That's the one I want. I press enter there. It's expecting a fraction. So I'll do 8 divided by 15. And I'll press enter. So that's going to be my angle measure. So let's see, do we want to round it to the nearest degree? So why don't we see angle B is 58 degrees. So let's see now if you can find the measure of angle Q. So pause the video, work on Q, and then come on back. So let's see. If I'm looking at angle Q, this angle here, the 4 is the opposite side. The 10 is the hypotenuse. So opposite and hypotenuse is sine. So I'm going to say the sine of angle Q equals opposite over hypotenuse. So I have to find the angle measure. So I want to do the inverse function. So my angle Q is equal to the inverse sine of 4 over 10. Let's go to our calculator and see what we got. I'll go to trig. I'll go to inverse sine. I'll do 4 divided by 10. You could do 0.4 if you'd like. 23.578, rounding to the nearest degree probably. 24 degrees. So you might be thinking, wow, it's really hard to remember all these ratios. Well, thank goodness there's a nice way to remember this. Some people like to pronounce this as SOHCAHTOA, where the SO, the SOH, reminds us that the sine is the opposite over hypotenuse. And that the cosine is the adjacent over the hypotenuse. And the tangent is the opposite over adjacent. You'll notice that if you write that down, that SOHCAHTOA, it kind of gives you a nice mnemonic device to remember these trig ratios.